Alright, 2.5 is another short section on the chain rule. So here in this yellow table are the chain rule rules. But I think it's easiest to understand the chain rule if you just see an example. So let's skip to examples. Alright, so suppose, let's get my pencil here. We have the function f of x equals x squared plus 5x plus 8. All to the second power. Now we could square that out, but we probably don't want to because it's much easier to use a chain rule. The chain rule says we're going to basically treat like this part here as if it were just a variable, like g. So if we're taking the derivative of g squared, then we would bring the 2 down in front, and we would decrease this by 1. So our derivative so far looks like this. 2 times x squared plus 5x plus 8, now to the first power. So we haven't really used the chain rule yet. We've just used the power rule. Of course, we can't ignore everything inside of the parentheses. We have to now multiply by the derivative of what's in the inside. So that would be 2x plus 5. In other words, the derivative of what we call g. And that's it. You don't have to distribute the 2 or try to combine like terms or anything like that. Mildhood Math might ask you to simplify sometimes. It should be clear, or if not, then just send me a message and let me know that you had the right answer, you just didn't simplify, and I can fix that for you. Because I really want the focus to be just on using the chain rule. Alright, let's look at another example. So I'm going to get rid of this. B. F of x is equal to the square root of 5x squared plus 5x plus 8. Well, we want to make this derivative friendly, so instead of having it the square root, we make it all to the 1/2 power. Now follow the chain rule. So we take the 1/2 down in front, times the inside, and then we subtract 1, so we get negative 1/2 now, and we multiply by the derivative of the inside, which would be 10x plus 5. And that's it. Example C. F of x is equal to x plus 6 over x plus 5 to the 4th power. Again, we're going to deal with the power first, so f prime, oops, I think I messed up here. F prime of x is going to be 4 times the inside to the 3rd power, and now we have to multiply by the derivative of the inside. The derivative of the inside, though, is the quotient rule. So it's the derivative of the top, which is 1, times the bottom, which is x plus 5, minus the top, times the derivative of the bottom, which again is 1, all over the bottom squared. And of course you don't really want to have those 1s there, so oops. Escape. You can cross those out. And for me, you don't have to simplify, but if you wanted to simplify the second part, when you distribute the minus through, you end up getting the x is gone and negative 1 on top, and then just x plus 5 squared on the bottom. That's what that is, simplified. Alright, 2 more examples. Hope you saved room. Alright, we have f of x equal to 5e to the 9x to the 10th power plus 6x to the 7th power. So far we haven't dealt with anything other than just e to the x, but the chain rule applies here too. So we know that the derivative of e to the x is just e to the x. So we start off, treating it like just e to the x. So it would be e to the 9x to the 10th power plus 6x to the 7th. Now we need to multiply what's on the inside. In this case, your inside is your exponent here. So the derivative of that exponent would be 90x to the 9th power plus 42x to the 6th power. And that's it. One more example. We have 3x plus 5 all to the 10th power. So using the chain rule, the 10 comes down in front, 3x plus 5 to the 9th, and then multiply by the derivative of the inside, which is 3. Alright, let's look at some applications. The radius of a circular oil spill after t minutes is given by r of t equals square root of 16 times t. Find the instantaneous rate in which the radius is growing after 26 minutes. Instantaneous rate means derivative. So we need r prime. But let's change our r of t to make it derivative friendly. This is just 16t to the 1/2 power. So r prime of t would be, bring the 1/2 out in front, times 16t to the negative 1/2, and then multiply by the derivative of the inside, which is 16. Then they ask us to plug in 26. So that's 1/2 times 16 times 26, all to the negative 1/2 times 16, and you should come up with 0.392 as your instantaneous rate of change at 26 minutes. During the first couple of weeks of a new flu outbreak, the disease spreads according to the equation I of t equals 4,300 e to the 0.036 t, where I of t is the number of infected people t days after the outbreak was identified. Find the rate at which infected population is growing after 11 days and select appropriate units. So, I prime of t, it's going to be 4,300 e to the 0.036 t times the derivative of that exponent, which is just 0.036. So that's your derivative, and then if you plug in 11, so I prime of 11, that's 4,300 e to the 0.036 times 11 times 0.036, and you should come up with 230.01. Now this thing is the number of people after how many days. So this is people per day would be the units. If it's a rate of change, it should always be fractional units like miles per hour, people per day, gallons per hour, something like that. Last example. At a price of X dollars, the supply function for a music player is Q equals 80 e to the 0.003x, where Q is in thousands of units. How many music players will be supplied at a price of $2.25? Round to the nearest thousand. So here you're just going to plug and chug. So X is the price, so we're going to plug X in, plug the 225 in for X. And you should get 157,000 units. Find the marginal supply. So marginal is derivative. So Q prime is equal to 80e to the 0.003x times 0.003. And if you combine these together, you get that Q prime is 0.24 e to the 0.003 x. That's just multiplying the 80 and the 0.003, you get 0.24. So that is your marginal supply. Then it says, which is the best interpretation of the derivative? Well, anything that doesn't say rate of change, like B and C and D, can be canceled because derivative is always rate of change. So the first one is rate of change of the price as quantity supplied increases. Or the other one is rate of change of the quantity supplied as the price increases. And it's going to be D because our independent variable is the price here. That's our X. Price is in dollars. So what's changing is the quantity supplied as the price goes up.